Um, Good afternoon, everybody. My name's Simon Smith. I'm chair of the CFCI, and I'm also chairing today's talk on modular construction. We have two speakers today, Patrick Usborne from Perpendicular Architecture. He's a joint founding director of Perpendicular Architecture with Eleni Thorne. We also have today Alan Dowdall, who's an associate at Ramboll, and he's a timber specialist at Ramboll. And we're going to talk about modular construction today. We've got two fascinating talks for you, quite wide-ranging, in terms of an overview of modular construction and DFMA, but also drilling down into some of the technical details of delivering modular construction, but also looking at some of the more interesting design sides of what can be created with modular construction. We're going to be recording today's session, so hopefully we're going to be able to make all of these sessions available to you online soon once we get the CFCI website sorted out. A few technical issues there. So in that respect, the speakers have asked today as well if you could refrain from taking screenshots today. In a couple of weeks, this will be all online, so you can then look at this to your heart's content. But please today refrain from taking screenshots. I should also mention that Alan is not at all camera shy. It's just that his camera is not working today. So Alan, you can't see at the moment, I'm afraid, but apparently within his slide pack, he might have a photograph of himself somewhere. So therefore you may still yet see Alan at some point in the talk today. The final thing to mention is Q&A. So we're going to have a 20-minute talk from Patrick, 20 minutes from Alan, and that should allow us about 10 to 15 minutes of Q&A, a hosted Q&A at the end of the session. We don't allow attendees to be seen or heard, I'm afraid, at these events. That might change in the future. But if you could raise any questions that you have in the handy little Q&A icon as the talks go on, please type in your questions there, and I will put your questions to Patrick and Alan after they've spoken. Okay, and then the final thing we'll do at the end of the talk, obviously we'll thank both Patrick and Alan for their contributions today, and we'll also have a little bit of an update on what next at CFCI. We've got some exciting talks coming up just before Christmas. So without further ado, Patrick, are you ready to screen share?
Yes,
Super.
I am.
Okay, over to you then.
Great. Let's see if this works. Right, hopefully everybody can see that first page.
Excellent, yes we can.
Brilliant, okay, great. Well, thank you very much, Simon. That's a very kind introduction, and very much looking forward to going through a little bit about modular construction. But in particular, what we're particularly passionate about is how modular can be regenerative, and it's kind of building up on the opportunity here to not only embrace modular construction, but also use it as an opportunity to tackle some of the other major issues which are happening in our construction industry at the moment. So 20 minutes, a lot of content, so I'm going to go straight into it. And first of all, just really setting the scene. And it's always good to start with this, and it really kind of highlights where we are in the construction industry at the moment compared to some of the other industries. If you rewind 100 years and look, for example, at the automobile industry or the agricultural industry to where we are now, they've made great leaps into the future, yet we seem to be still very much stuck in the past. Certainly in terms of the volume house building. I mean, of course, when you get into high-rise skyscrapers and so on, it's a different story. But certainly in terms of volume, we're very much behind, but at the same time have great potential. So just first of all, what is modular? I'm sure everybody probably knows this. The government very helpfully have brought out 7 categories of what modular construction is. And there's a real issue in the fact that there's a perception issue where a lot of people feel that modular means volumetric, when actually there are so many other items, or it's almost it's like a menu in which you can choose, and volumetric is one of many different options that you can go for. And actually what we found is that the most optimist, or the most ideal combination, is using some different categories, and not necessarily just thinking about volumetric in itself, but how we could have structuralized panels or off-site components. And we found historically that actually if you're focusing on, in particular, categories 2, 3, and 5 as a hybrid solution, then you're getting quite enormous efficiencies, where the proportion of any project, which is the pre-manufactured value, can even get to up to 80% or so, which you're doing pretty well if you're getting to that percentage-wise. But we're still not on target, and I think there's still a lot to do. Mark Farmer in particular produced a review in 2016, and the government's white paper, which I know the CFCI were talking about last week, there's still a lot to be done in terms of specifics, to see actually, making sure there's actual targets to go for. So what I just want to talk about is a project which we're doing at the moment, which is funded by the government. We are working alongside some other founding members of a collective which we've called the Positive Collective. And we've got a number of supporting partners which are helping us in this government project. And what is very key is that any modular project really needs to have a complete rethink about how you procure any modular project. And whereas before, it's traditionally is very much a linear process. You go through the different RIBA stages, whereas with an offsite or a DFMA designed for manufacture and assembly, it's very much a collaborative effort. It's bringing all the minds together right from the outset and kicking off in the right direction. And it's only through collaborating where you can really achieve the full value of any offsite modular project. So there's some really fundamental issues going on here, and again, this is a real opportunity for modular construction to tackle a number of issues head on. So it's not just in terms of building more housing. Yes, we need quantity, but also we need quality. And how can we improve the quality, in particular, of our housing, volume house builders at the same time? And in particular, for example, one statistic here, which is the top left one, is improving the health and well-being. The NHS at the moment spends about £1.5 billion a year on health issues which could have been resolved through better living standards. So in particular, better heating in homes. So there's a real need here, an opportunity to tackle all of these issues head on. And this is what our project is doing. Actually, what we're doing is going beyond the idea of having a balanced society, where we are working on all these 4 areas and going beyond that, and thinking about actually how can we regenerate society, how can we make it better, whether that's the health and well-being, or whether it's to do with the environment and biodiversity loss. So there's these 3 main models which we've been using for our projects, and I would highly recommend, actually, if you've got a moment during lockdown, one rainy evening, to download and read through these. All 3 are in particular are really quite clear, and they go beyond the construction industry, actually, into something where we can use, and it really sets up a very clear framework. So the 5 capitals of sustainability in particular is something that we've been following. So I'll leave that. I won't go into any further detail on those 3. So first of all, quality. Setting as an architect, and it's incredibly important, and I find it so frustrating that it seems to be an awful lot of modular design which is coming through in the UK now, which tends to be very boxy, not particularly very good to look at or potentially to live in. So we've got a real opportunity here, again, to respond to the local vernacular, the local culture. And it's about understanding what has been done historically, what is the local vernacular, and then trying to modify the designs accordingly, which is very possible to do. So we're moving away from monotony and poor quality design to something which is a little bit more flexible and customizable. HTA produced the image on the lower left here. So first of all is, what can we build with? And the first thing with modular in particular is understanding actually every component within a modular building will have a different lifespan. And that's whether it's the structure itself, which might last 100 years plus, all the way down to the fit out. And how you design this in to enable change of these layers at different times during the lifetime of the building without producing waste. And I think this is really, really quite key, is embracing the circular economy and really thinking from the outset about how we can modify the buildings in the future to make it easier and less wasteful. At the moment, for example, 13% of construction materials end up in the skip even before completion. So on the lower left here is just a very simple square diagram of different materials and how much materials you can produce before reaching 1 ton of carbon. And what's quite clear, and I think everybody realizes this already, is that actually one of the main drivers to produce zero carbon or also challenging the biodiversity loss is embracing natural materials, and this is imperative. And that's not to say we should be designing with 100%, we should be using the right materials for the right job. But using as high as proportion of natural materials is vital to be able to achieve zero carbon by 2050, if not before. So that's what we've been focusing on in our research project. So first of all, where can these natural materials be extracted from? At the moment, we're importing, I understand we're the second largest importer of engineered or timber in the world, which is after China. And we've got a great opportunity here, as per the government's push, actually across governments, to wanting to grow more forestry, more woodland. And we need to do this sensitively. We need to plant the right trees in the right locations. But we've got an amazing opportunity here to actually produce our own timber in the UK. And the map on the right here, it illustrates locations where we could grow timber on low-grade agricultural land. It excludes high-grade agricultural land or peatland or high land where it's not suitable. So these are all areas which are suitable for growth. So there's an amazing opportunity here to increase our own industry of timber. So in particular, and yes, we do need to have a good range of different timber, but in particular, one species is particularly good for the construction industry, which is Sitka spruce, which has got a very good growth rate and can produce a large volume of timber with a relatively short amount of time. So part of our research is actually how much timber do we need, how many trees do we need to grow in order to manufacture some of our designs that we're coming up with. And we've actually calculated that we only need one mature tree to build one house, one typical size house, which I'll show in a bit. There is inevitably some waste and some carbon which is lost, but actually we can, on the whole, every tree which is extracted, we can lock half of that carbon that the tree is stored away in a building. So our design, which we've been doing with the government and our other collaborators through the Positive Collective, uses the whole idea of this. It uses homegrown, low-grade engineered timber. So very, very thin, 80 to 100 millimeter cross laminated timber panels with a wood fiber installation. So we're really trying to think about that tree and how we can make best use of that single tree to be able to produce our design. So the way in which we've built it, I'll describe in a little bit. But again, this is really trying to get to grips with not just the construction as a modular approach, but also the way in which we live in it too. So the difference here is that we haven't gone for volumetric, as I mentioned before. We found actually it's much better having more of a hybrid modular approach, where actually it's more of a panel and chunk, we're calling it. So it's a balloon frame construction, where on the left here you've got a full external wall produced in the factory, which can then be lowered in site, similar to the roofs. And just a very simple cassette where you impregnate the services, which can be also installed in the factory and then lowered and secured in place. So this is our approach, which through a lot of research we feel is the best option. So can it be regenerative? Yes, it can. So this is what we found through our statistics. Actually, through looking at every single element of the house, and we've also designed a townhouse and an apartment typology as well, not just our two-story house. We found actually we can lock away more carbon that we produce during the lifetime. So just to explain, the life cycle is really being based on these different criteria. You got the A, B, and C, and D, which is during the lifetime of the whole building, not just during the construction. So we've calculated during each stage of the life of the building how much carbon can be captured, and how much inevitably we need to use some concrete, for example, in the foundations, and some steel and metal and so on. So in terms of the operational carbon, what we're anticipating is that, well, the best method to use to enable us to reduce the demand on energy is actually going to a passive house standard. And I think there's been a lot of issue because of the criteria and of enabling us to reach the passive house standards, which we found we have. And I think actually using engineered timber has helped greatly with that, to produce a sealed house. And we've designed the whole massing, the roof geometry to attract as much sunlight onto solar PVs as possible. But what's really key is what this graph is showing. Actually, what we haven't done is we haven't gone for ground source heat pumps or any other expensive technologies. What we've done is we've estimated, and this is not our figures, but we've realized that certainly by 2040, if not slightly earlier, by 2030, the carbon footprint, so the annual carbon emissions from direct electricity from the grid, will actually start to converge anyway with more sustainable forms of energy production that you see now, such as ground source heat pumps. So we felt, instead of investing a lot of money into that technology and the issue about replacing it over time, let's rely instead on direct electricity. So overall, compared to a typical house of today, where the embodied and the energy used tends to be much greater, you're losing energy, you're putting carbon into the environment. What we found through our research piece is actually we're storing away to these ratios as well. So we're storing away carbon. So in essence, yes, we can make it regenerative in terms of the environment. So we've also researched quite a bit into actually how we're going to make these panels and chunks in the factory as well. So we've worked with collaborators up in Scotland, in particular ecosystems, to really understand the process in which we need to achieve. And we've even designed a factory to enable us to understand actually exactly what this process is and how many units we can produce every year, for example. This diagram is, very much part of it. So it's a very clear diagram, showing every single component. Now, I think that the digitalization is really important here. Actually, how we digitalize the design process to enable us to understand exactly all of the components and how they come together in what sequence, and ensuring that they're able to be adapted over time. And that also, through the digitalization, allows us to tackle customization. I think this really goes back to the original diagram about the responding to local culture and the vernacular. is actually working alongside the local planners and coming up with a menu of potential different options, where ideally the end user, the customer, can choose what they want. And we've designed some a various different menu of biogenic designs. And again, this is very important to be able to move away from this cookie cutter architecture and actually design something which is much more about the local culture and the context. So in terms of adaptability, this is a kind of a plan of our two-story building. And the key here again is allowing users to be able to adapt. And I think this is one issue about modular design, is that you don't always are able to allow users to adapt their houses over time. And even though there are some CLT elements which we need to retain, there's many which you don't. You can move walls, you can move kitchens, you can put platform lifts through there. So we're kind of thinking about, as residents become older or they have an older relative coming to stay with them, how you can adapt the plans is really important, or wherever you want to put the kitchen upstairs and so on. So I think this is key, is having adaptability in a modular approach. And then also producing, really beautiful designs inside as well. Where, there's an issue here with making sure that we don't expose too much cross-laminated timber, but we do want to celebrate it. We want to celebrate it as a material because it is a lovely material to use as well.
Patrick, 2 minutes, yeah.
Perfect timing. That's great. I am about 2 minutes away too. So, and also, for example, our townhouse here on the right, and trying to bring biophilia into the design as well, without compromising the space, is really key. But what's really important too is that it's not just about the house; it's also about the space in between. And I think this tends to be lost in terms of large-scale developments up and down the country. Is how we can bring the community together and how we can really think about community cohesion. So this is what we've done from the outset. It's thinking about who is going to be living in these communities. So we've come up with these fictitious characters and tried to really drill down and understand what they need, what they want, to be able to bring them together and support one another, and how they move around the site. So we started placing, first of all, not the buildings, but their social infrastructure, the social, the green and the blue infrastructure. And through understanding what their social needs are, then we can start to place the buildings. And in a way, we're looking at the future as well. This is very much a car-free development. We're thinking about walkability, how residents will walk around the landscape, and through walking or cycling, there's some friction there to be able to allow them to rub shoulders and to work together. And that's just some images to end on, which is trying to bring this to life as well, and making sure that we really can think about the community as well as the house. And I think this, as a summary, goes back into the very first question: can we make modular regenerative? And a bit of a whistle-stop tour there, but there's a lot to consider. And I think, again, yes, it is about the technical aspects of it, but it's equally important to think about place, health and well-being, and inclusivity as well. And I think that's, if that's okay, that's where I'll end.
Super. Patrick, perfect timing. And thank you very much. We're going to pass on to Alan in a minute, but thank you for a fantastic presentation and wonderful illustrations. They're beautifully illustrated, in particular the scale extra extract that was on the one of the images there. I thought that was a nice touch. Right. We won't dwell on any questions yet. We'll hold those at the end. So Alan, could you now share your screen, and we'll pass over to Alan for his talk. Alan, you're muted at the moment. So, right, we can see your presentation, but we can't hear you yet. Right, there we go.
How about
That's
now?
It. Excellent. Super.
Okay.
Good.
Let's get this going.
Right, I'll let you know when we 20 minutes, so I'll give you a warning
Okay,
at 2 minutes.
great.
Yeah. Super. Thank you.
I'm just gonna stop that for a second. Bear with me, I'm just going to share the wrong screen. That's rookie area.
That's okay.
There we go. There we go. Okay, can you see my screen?
Yes.
Okay,
we're getting
brilliant.
we're getting the I don't know,
Yep.
Patrick, if you're getting this as well. You're seeing the next slide, but it doesn't matter. Let's just
I
continue.
am, yes. I can see the next slide too.
Alan, don't worry. It's
It's okay. It's okay.
Okay.
We'll just have to survive.
There we go. Perfect.
Okay, great.
There we go. Perfect.
Yeah,
IT
you.
issues as always. So, well, thank you for great presentation, Patrick, and thanks for the introduction, Simon. My talk is going to be very focused on the volumetric aspects of modular design, and because my camera isn't quite working, I thought I'd just stick a slide of me in so you can put a face to the voice, if it works. So that's me, in case you haven't don't know who I am or what I look like, and that's actually a younger version of me. So I've aged considerably since then, but not to worry. Yeah, so I just want to quickly touch on volumetric modular and product design, and how the two of them go together, and then do we need to sort of rethink a little bit if we're doing a product design at the same time as a building design. I think we're all quite familiar with the Mark Farmer reports. It was quite a game changer for everyone, and it had more of an impact, I think, than the Latham report or the Egan reports. And since around that time, since that came out, we've certainly seen a lot of developers who are moving into that modular, volumetric modular aspect of things, and they're sort of finding their feet in developing the products and the modules that they want to create. And this talk is very much going to be around my experience with the new build and the modules that they have come up with. They are CLT modules, and I'm a fan of timber, so I like to talk about it. We've got about a couple of projects with them that we're looking at. The Beechwood West, this is 251 homes in Basildon. Really interesting, because these are modular schemes, but when you look at this is CGI, when you look at that, they don't look like your typical box of a module. They are quite different. And in this case, there's actually a possibility of 1 million homes that you could choose with this bit, because it's fully customizable. So you can have a certain house type, and there's an app on the site where you can basically pick everything down to your brass taps, if you want to, your floor finishes to the facade on it, and that will get pre-made in the factory and before you step into it. You can also see the price, which I think is really innovative. Yeah, if you can have a game and find the most expensive house, let me know the price. I think that would be quite interesting. We do have a couple of more developments with them at Langdon Centre, just down the road from that, which will be apartment type modular developments. Again, don't really look modular, but are. And a similar one in London this time with Watts Grove, and that's got, because that's in London, that's got implications which I'll touch on in a minute. But the journey of a module should be relatively simple, right? It's a box, and this is an example of our carcass. We would try to make them as carcasses if we can, so that sort of customizable bit in the middle, where you could change around the aspect of the house, is not really affected by structure that would get in the way from there. So do it in the factory, lift it into place on the back of a lorry. When you design connections, you don't normally really see them in full use. When you design a connection for lifting, and you see it being lifted there for the first time in the factory, there's a little, you can't help but feel nervous sometimes, I think. So I was there when they were doing that, and that was just like, I'm sure I've got the numbers right on that. I think on the back of a lorry and into our house. This is a bad picture for myself. That seems quite simple, I would have thought. It looks quite simple, doesn't it? But actually getting from the start bit of that to the end bit of that was quite a long journey. I think about 4 years in general. So that was a long road ahead of us. And it started off, we thought, really quite simple. You know, modular, volumetric modular, it's just a simple box, right? And that's what I certainly started off thinking at the time. And this is probably one of the first sketches that we put together, and I thought, actually, you know, nailed it. We've got the design in one place. It evolved a little bit beyond then, but not massively different. The issue is actually thinking about the structural strategy is quite the simple part of a module. You want to more think about from the inside out, so from the minute bits to the micro bits to the macro. Whereas if you start from the large scale in, you end up coming into problems. Then if I think about the Ariba DFMA strategy that goes through it, and align that with trying to deliver a building at the same time as trying to develop a product. I'm not sure the Ariba stages account for that. I think they account for if a product is being developed, and then you can go ahead and design your building. But trying to do one hand in hand makes it quite an interesting process. So if we look at certainly some of our projects, how we've spent our time throughout those stages, this is probably a standard type S curve that you have throughout the from 0 to 5 in a cumulative manner. When it comes to looking at the modular aspect of it, you could quite easily get to a stage 3 scenario and have your concept and develop design, and then just once you start getting into the details, it can really ramp up quite a bit if you haven't smoothed out the process beforehand. And on one of our projects, we did get caught like this. So it's really a key thing to really zone in on those details as much as possible from the start. And again, thinking about a building or a product, there's actually quite a lot going on when you're designing a building. There's a lot of many different factors going in place. And it's the same again when you're doing a product. There's also slightly different factors that come into the equation, and there's a bit of an overlap within that. So trying to get everything into one place it's hard work, but you're going to struggle with it. And so maybe we need to think about it in a slightly different manner into, well, what's the cycle of a product look like? And this is sort of taken from a standard technical industry map of how they develop phones, for example, in that there's an initial stage of actually developing that product, a bit of an introduction to the market, a nice growth phase, the product matures, and at the end of maturity, it will either die away or it's reinvented somehow. So if I take the Nokia phones, for example, they seem to have didn't reinvent so much, but have moved away, whereas iPhones probably have reinvented and moved themselves on. So there's a level of development that always happens, and then recycling at the far end in terms of refining that development. So we've some of our bids and things, we've put together processes to the clients that we think you want to actually be doing testing, analysis and feedback for a certain stage, get that into the production. You're never going to solve it all. Have the delivery of a building, and then we go around that in circles again. So it's not a matter of doing a design and leaving it. It's coming back several times throughout the process to so design, refine, and evolve the details that you're going through. Build the building, and then go through the whole process again. So that's kind of the design aspect of it. Then we think about modules, the journey of a module. The physical question is, what is the actual journey? Where is it going to? Because that makes quite an impact into how you're going to design it. And where is it got to go? So this shot, for example, if you're going past the M25, then you're going to have very different restrictions on what sort of size of module you're going to get there, and that's really going to impact on your architecture for your spaces and how that building will ultimately look in the end. But from a structural point of view, for us, thinking about actually what is the design phases of each of our pieces of structure, generally going to be the 4 principles of it. And normally, traditional build, we're very good at thinking about what happens in the building, how the building behaves, and even while it's during construction, what it behaves like to what it's going to behave like in its final use. What we're probably less sure about is how that's going to be assembled. What the impact on our module is when we lift it from the assembly line into the back of a lorry. We drive it, so there's some loads on it there, to site and lift it again, but in much different conditions than we've lifted before. So the actual stresses and things that happen to a module are quite different from where it may end up having the stresses that it has in a building itself. So actually in the final state, it may be in the most relaxed environment it's actually experienced to get to that point. And that really sort of could lead you down to a route of, well, this is what we think first, but we need to go back and do those cycles, do those testings, evolve our designs so that we're starting to fine tune the process. And that really happens when you have partnerships and you have several projects. You can really sort of make a lot of use of that, of going back and redoing things. This is an example of the testing lift we've done on one of our modules. This was just looked to prove that the CLT is acting as a deep beam or a beam of sorts, and we can really make that work. And we looked at what sort of deflections that this stresses, how much the connection node would spring value onto that, and that connection actually was quite beefy, really, to go through. There's a lot of steel, a lot of plates and screws going into it to make that work, and quite a big lifting node as well. So going back to looking at then evolving that design, and trying to just get it going really smart, we kind of looked at, well, maybe we can change that rather than a plate. It's a reusable sort of thing that's sitting down into the wall and the connection is there. Or in the end, actually, you know what, we're not going to have the plates. We're going to strap it and then lift it from the underside. And that actually, because we have several straps, then we can reduce the amount of tensions and stresses that are in around openings on the module. And also talking, it is a true partnership, really, when you want to have, so you can have those open and honest conversations and going through those cycles and refine that design. And part of that means actually just sort of almost living in the factory. This is my colleague Gustav, who works with me during these things, and we seconded Gustav to the factory for I think nearly a year, and the value that's got in just sort of, when you're, again, products, it's almost invaluable because you can answer questions live on the spot. And we used to do a lot of having site roles on our construction sites, but actually having factory roles, I'd say, is just as important to be able to add real value and quick decisions and be very reactive on things when you're developing something quite new. This is probably another example of refining that design. One of the original designs that we had, as you can see, we've got a nice box frame around the opening here, some more steel around the end, where it did a bit more work after having that lift and built the test cases. We're actually able to remove quite a lot of that steel, and that's quite a lot of saving, and also hassle for the factory to be able to install all of that steel and fire protect it. It's quite a costly sum for them. So and also then to be able to connect it all together, it just makes it a bit harder. So refining design is a key thing to be able to do in developing products. Our initial houses had some stability walls to the stair. We've got very little walls on the outside face to make that house sort of stable. So internal stability walls worked quite well, and we do them a lot on CLT buildings, where when you come to a module though, you've got to hold that down somewhere. So that means access hatches, and it means someone trying to get their hand into a foundation in a place that they have getting access to. So the problems and the logistics of things can very quickly escalate if we're not sort of trying to do things internally, and also it restricts the freedom of the space to do that. So we spent a lot of time with the client and evaluating things and coming up with systems that can free up the need to have that access hatches and hold things down by using a heavier facade, heavier CLT, thicker CLT facades to act as a portal frame of sorts and provide that stability. So you're only ever accessing things from the outside, and it's in the modular world, trying to get access to your connections is a big consideration. And then thinking forward about connections, also thinking about connections and tolerance. When you have something that's a bit taller to build, trying to make sure the build it doesn't move too much or slip, but also has the ability to be not quite 100% accurate. So there's a little bit of construction tolerance. That was quite a big thing for us. The stability of these modules are provided by the CLT walls themselves. They're all individually almost stable as you build them. So there's a bit of a lot of walls to think about. And that connection detail went through many evolutions before we even kind of got it right. At one point, we started offering prizes to really get to that point. You know, we spent no expense to make sure that our engineers are rewarded with that. When you put this up next day, it was gone. The module connection prize had been used, and these guys would cherish their prize well in making the most of that. And that connection detail just evolved into something quite well. And because we were quite happy with that, and the client was happy with that, that can be modeled properly in a 3D environment. And once you model it in that environment, you can put data behind it, and you can do lots of really fun things about scripting it and getting it in the right connection node and the component into the right place. And because then you've modeled it, you can really help the client in terms of here's the data behind that, here's what you need and when you need it. So you can have dashboards that come from there. And again, that works when you've got a true partnership on things. Oops, I've doubled up the slides. But all of those components, they sort of add up, and you can really sort of make the use of that. So from a factory, there are basically a site indoors. So ordering the right material when has got quite an advantage to it. So that evolution is eventually going to lead into something that I think is just going to start to automate our buildings. We're really going to come down to a line. We have the steps in every refinement are quite big, and we then once that will come to a level of fine tunement, that means that actually the automation bits can just happen instantaneously, and we can create scripts that will work out where's the best place to put the certain types of modules, and where they can be acting best, and whether they need a core or they can be self-stable, and that frees you up to then refine the details rather than spend the time on this concept, this scheme. So that for me means that actually going further down the road, if we think about the time we might spend in between the Ariba stages, between 0 to 6, I believe that we'll come to a scenario where we're defining what the strategy is for our building. The bits around the middle, so stage 3 and 4, are almost going to be automated, and we can just create that from a program. And then the detail is where the R&D is, and that's where the fine tunement is, if regs change or anything happens, and that feeds back into the strategy. So you might end up with a process on a project where you have a strategy, you implement the strategy, you review the lessons, the R&D, you refine design, and you put that back into the strategy at the start.
Alan, 2 minutes.
I'm actually unfinished quite now, so I've
Super.
Depends that. So I've last slide there. Thank you.
Thank you, Alan. Sorry to cut you short there. Fantastic. I mean, top marks to our speakers today for keeping absolutely on time. So thank you both. Patrick and Alan, we have a number of questions that our attendees have raised today. So if I go through them, I think one of the first questions that seems to be quite common, and this is to both of you, perhaps Patrick, if you want to answer first, is so there's some questions around fire and the use of timber. There's some questions around volumetric or modular and mortgage lenders and builders being convinced that this is a safe and alternative and effective solution. I mean, so how? I guess the question for me then is what you're doing here is unusual in terms of you're trying to change things. In some respects, you're pioneering. I guess that brings risk, that pioneering, and I think if I can frame those questions in terms of risk, what's your view on, Patrick, risk and the market accepting what your concept is? Have you had any feedback from suppliers, from the insurance industry, or have you consulted, I guess, on that area? And then Alan, to you, I mean, you're actually building some of this stuff. You know, it'd be interesting to hear some of the challenges perhaps you've had from the insurance industry or mortgage lenders. So Patrick, over to you first.
Yeah, no, good question. No, I think that's a question actually which is always on the top of the mind when we talk about engineered timber in particular. And yeah, I've been working with engineered timber for about 15 years, and so I have come across numerous issues over that period of time, and certainly after Grenfell in particular, it's become much more difficult to be able to produce engineered timber buildings. There's undoubtedly, there's no question about that. And I think also, actually, we were just speaking before we went online about the increasing issue of designing out issues regarding water ingress. And I think that's particularly important as well. But fundamentally, though, what we need to remember is actually we've been building with timber for centuries, millennia, and we've almost forgotten how to build with timber. And I'm not citing engineered timber in particular there, it's actually just building with timber. You know, whereas millennia or centuries ago, the craftsmen back there understood very much about water ingress, for example, and designed their buildings with jettying, for example, or raising the timber off the ground, or having pitched, not flat roofs. So it's very much about remembering how those designs evolved over millennia and actually thinking outside of the box, quite literally, about how we can design with timber. So we shouldn't expect to squeeze in a timber design into the form of a design of a building which might have been historically made out of concrete. We need to adapt our designs. And actually, I think that's it's quite interesting what Alan mentioned, is that at the beginning about it doesn't look like modular. And I think actually there's an opportunity here, is that one, there's by embracing modular design, we don't necessarily need to feel we need to squeeze it into a traditional look. It doesn't need to look traditional. You know, why can't we actually accept that modular is different and designed differently for it. We need to make sure that we're making the most out of it and designing for it. So I think that's really important to remember. We've got a rich history of building in timber in the UK, and it's just being sensible. It's just being very sensible about actually how we design from the start to ensure we design out for fire and water ingress in particular.
Thank you, Patrick. Alan, some experiences that you may have had in this journey on modular in terms of volumetric construction in particular. Have you met any barriers, projects that were cancelled, for example, because of certain bias to volumetric construction or even timber construction?
Well, yes, I think is the answer. So that and it usually comes down to a couple of questions. One on fire and insurance aspect of it, and actually those two are quite linked. I'm finding that engineers, an engineer that I am, I like data and information. And I think there's a lot of data and information behind any project. Probably we could be doing as an industry, being better at representing what that data is to insurance people and to that market. Mm-hmm. Because if you don't understand something, you put a risk factor against that. So if it's then the onus is on us to explain whether that risk has been mitigated or how it's been addressed. So my wording to clients is insurance are a stakeholder that you need to address from early stages. And on the slides I had about journeys. Well, if you end up at the end of a journey and you haven't taken key stakeholders with you, then you're going to fall foul of that. So it's that early engagement and communication and understanding things from their perspective so that you can address those concerns is the way forward to be able to do the schemes that you want to do.
Super. Thank you, Alan. Some wise advice there. We also have a question here regards the sort of the modular construction and being hailed currently as the next big move in our industry. And the question is, why do you think it's taken so long for this to become a reality? I guess that's referring back to things like the Egan and Latham reports, which asked us to adopt modern methods in terms of manufacturing, citing the automotive industry. And those reports are going back 15, 20 years. So Patrick, why do you think it's taken so long, and what's the catalyst now that's meant it's happening?
Well, yes, good question. So there is why is it taking so long? It's a good question. It's purely down to the complexity of designing and having constructed a building. Buildings are rooted in the ground, unlike a vehicle. So with that comes much more complexities, and in a way there is no reason why we couldn't have done it earlier, and there has been attempts. You go back to post-war modular buildings, we were doing it back then. So the issues though back then is that there wasn't a full understanding of materials or thermal envelope of energy savings, but we now have that knowledge, and we've had that knowledge for a couple of decades. And so I think the excuse has been quite recent actually, and if anything, the technology is there, the know-how is there. I think it's allowing it to happen. It's a little bit of a carrot and a little bit of a stick, and we do need a little bit of a driver from the government, which they are doing. But also we need a little bit of a groundswell, I feel, from people who are going to be living and working in these buildings, to actually expect more from our developers and house builders and so on. And even though our project is very much focused on the smaller scale buildings, residential buildings, that's not mean to say that we can do the same for other types of buildings as well. So Yeah, I think there's multiple catalysts now, which I think I've highlighted in the presentation. You know, again, health and well-being, inclusivity, the environment, biodiversity loss. There's a huge number of issues here. COVID-19 as well. They are all pointing towards us needing to embrace modular construction.
Thank you, Patrick. Alan, what's your view on this question in terms of catalysts?
I think Patrick hit the nail on the head there right in the end. In that, if we haven't had to do it, then it's not been done in the construction industry. So while the Ethan and Nathan reports came out well over 30 years ago, it wasn't a necessity. It wasn't absolutely. It wasn't going to. If we didn't change, then it wasn't going to fundamentally impact on the construction industry. Now that we've got aging workforces and lots of other forces are against it, we have to do it, really, because it's not going to work otherwise. We can't continue to go the way we're going, because in a few short years it'll be, well, just not non-deliverable.
And also there's an issue there with quality as well, and I think there's a misperception that modular means quite cheap builds, when actually it's anything but. You know, there's an opportunity to have a much better quality building built. So I think it's a good thing overall, so long as it's, as Alan has said in his presentation as well, there's a collaborative approach to getting it right from the start.
Thank you both. I think it's potentially this sort of perfect storm, if I'm allowed to coin a phrase, of a skills shortage that we have, a digital revolution that we're supposedly going through, and an increasing population in the UK. So in terms of housing shortage. So we've got 3 more minutes, and I'm going to draw things to a close. So I'd just like to say to both Patrick and Alan, thank you very much for your presentations. I think it's fascinating to have 2 people both working in a pioneering area of our industry, potentially using wood as a construction material again, and doing that from, I think, one of the least wooded counties in the UK. You know, are 2 of the UK's pioneering wood and timber gurus. So thank you very much to both of you for those fantastic talks. So that leaves me then just to announce a couple of parish notices for the CFCI, and it's linked to our talks we've heard today, in that in December we as the CFCI are going to be running our climate emergency conference. That was a conference we had planned to run physically back in March now, and we're going to run that online now. It's such a big topic that we're actually going to run that as 3 sessions. The proposal is on the 2nd, 9th and 16th of December, we're going to have 3 themed events, lunchtime events, and that's going to be run by 2 of our trustees, Meredith Bowles and Joel Gustafsson. So keep an eye out for the presentation, for the CFCI notice on that. That should be a really interesting series of seminars before the year end. So everyone, thank you very much for joining us today. We had a good turnout. Nearly 100 people came along to listen to Patrick and Alan, and thank you very, very much everyone to coming along today from the CFCI. Goodbye. See you again in a few weeks. Bye everyone. Bye Patrick. Bye Alan.
Bye.
Thank you.
Thank you.